Nemo 3D. Text. It is the object type that is used the most often, and unsurprisingly, it has a lot of properties. So let's go over them in more detail. Create a new project, name it, then create a page and add a text object to it. Also create a new, white material for it. Justify the text to the center and make it bigger so you can see the effect of the properties that we are going to discuss. For text, you can choose any font installed in Windows. You can see the complete list of available fonts there. Choose a few to see how they look. In the end, let's settle on Calibri. Nemo is a 3D broadcast graphics application. For 3D models, it uses polygons, or more precisely, triangles, to draw everything. A triangle has all three of its points on the same plane, so it is easiest to build the faces of a 3D object from triangles. A modern GPU can draw triangles at an amazing speed. Text, even if it looks completely flat on screen, is also built as a series of triangles. The more curve a character has, the more triangles it is needed to approximate its shape. Let's see how this looks in practice. Most of the time, the application draws all the objects as shaded polygons, but it can also show the edges drawn as lines. We need to increase the width of those lines to make them clearly visible. You can also set the material to show only the vertices of the triangles the object is built from. Okay, let's go back to drawing shaded polygons, and add depth to the text to make it a real 3D object. First, we need to add another material, this time, to the extrusion part of the text, and make this material black. Then increase the outline property from 0 to something that looks good. The text now has a black border, something a CG uses quite often. But it is still 2D. All the vertices are on the same plane. Next, we add some depth by increasing the extrude property. This extrudes the text along the z-axis. Rotate the text around a bit, so it clearly shows that it has depth. There are other properties like bevel that you can use to create more sophisticated 3D models, and shading would also look much better with lighting, which is switched off by default because it is rarely needed. But all these would require a separate tutorial. You can also check again how much more data is required if your text has depth. The significance of this will become apparent soon. Let's reset extrude to 0 but keep the outline. Another way to increase the contrast between the text and its background is to add a drop shadow. A drop shadow is really a copy of the object that is flat, has a different color, and its offset in the X and Y direction can be adjusted. Let's make one that is a semi-transparent black and adjust the offset that the shadow is to the right and below the text. Since the drop shadow is also a model that is built with triangles, it is not surprising that its edges look a bit hard. We shall see later what we can do about that. These are the most common properties you can use to adjust the visual appearance of the text. Let's move to some of the others. Add another line of text, and if necessary, make it a bit smaller, so both lines are visible on screen. If the two lines are too far, for example, because you know you are not using uppercase, or any special and tall characters, you can adjust the distance between the lines using the property called leading. You can also set a maximum width value that any line of your text can occupy. This is very important when you want to make sure that names of different length do not overwrite boundaries set by the design. If the width of the line is bigger than the value set for max width, first, the kerning between the character is decreased. then the width of the characters. And if that is not enough, even the height. Of course, you should use this value with caution. There is a limit to what text can be reasonably squeezed to still look legible. Reset the value to 0 if you do not want any squeezing to occur. On the other hand, if you want to increase the distance between adjacent characters rather than decrease it, you can use the kerning property. It can be animated, making some nice-looking effects possible. If you want the characters to be at the same distance regardless of their width, fonts like these are called monospace fonts. You can use monospace value to set the fixed distance between adjacent characters. Usually, clocks and timers or timing data require to be lined up like that. You can even add a rectangular background to your text that automatically resizes according to the width and height your lines occupy. This is basically a rectangle colored by a separate material that is located closely behind the text in the Z direction. You can set an additional offset in every direction to make this background box the right size. Since the text we used to try its different properties was really big, probably bigger than any you would need for a real project, you probably noticed that round edges do not look especially round. They are really lines that only approximate a curve. This is the logical consequence of using polygonal models or triangles to build everything. You can subdivide a curvy edge to more triangles if you need a more detailed model. There is a quality setting that influences how precisely the font data is converted into triangles. This property defaults to good, but there are 2 more settings above good. Let's try the highest setting to see the difference. Hopefully the reason why we discussed how a model is built from a font became quite obvious by now. Although computers are fast, CPUs are fast, and GPUs are even faster, but the process still takes time. If you have a lot of text on screen, generating it can take a measurable amount of time. Particularly if you add things like outlines, extrusion and bevels. Creating the models on the fly can become problematic. If you update a text at regular and small intervals, like a timer that shows smaller increments than a full second, the process may get too slow. However, there are some things you can do to speed things up by a lot. Although Nemo supports the full range of Unicode characters, provided that a particular font supports it, most of the time you do not need to use exotic languages with complex scripts or many thousands of characters. If there is only a few hundred characters in the alphabet of the language you support and it uses a simple layout, you can consider pre-converting all characters and storing them. This speeds up the rendering of text significantly. If you have set up the font you wanted and in the style, bold, italic or bold italic, that you wanted, click on the Store button to convert the range of characters that you intend to use. Here, you can select the range of Unicode characters that you want. ASCII and currency symbols are pre-selected. You also get a little help from the application that shows you the total number of characters that are going to be converted according to the current selection. When finished, click on Convert to start the actual conversion process. All selected characters are converted into lots of triangles, according to the properties set for the text object. In addition to that, another conversion will take place, to create a special format called a signed distance field. This is basically a bitmap, but instead of pixels, it stores data to create a graphics format almost as precise as vectors would be, but it is much easier and faster to use. It also helps with effects that are very useful for a CG. Click on Convert and wait for the conversion to be finished, then click on Done to get back to the properties of the text object. When you store font data, you do not have to go through the same process for every single text object. If you set the same parameters for a text object as for the one you used for storing it, the application will automatically use the stored data. Let's try how text looks using signed distance field data. Click on the 2D option. Here, the properties look a little bit different. Outline is still there and there is a glow value next to it. Outline does the same as with 3D text, except with glow, you can make the outline look softer. Try these values for a bit to see what they do. There is a drop shadow. Not surprisingly, a drop shadow is a 2D effect after all. In addition to the same properties, there is a softness value now that you can use to make the drop shadow softer. It looks much pleasing now. With edge softness, you can even make the face of the text softer as well. Since the changes these properties cause can be rendered very fast because of these special kind of data that we stored, the value of these properties can also be animated. You can set keyframes on them. Within reason, you can also adjust the weight of the font and keyframe that value as well. Of course, this is just an effect. If you change the weight too much, artifacts may appear, so use this cautiously. You have already seen how to create an input tag on the content property of the text. It deserves an explanation why it is necessary to animate a property like that. Sometimes, not even rarely, you may want to change the current content of the text to a new one, but not at the start of the playback of the animation, but somewhat later. Of course, a keyframe on a property like that does not create a change over time. It simply changes the text at the precise frame set for the new content. Until that frame, it will show the previous content. Let's see this in practice. Set a keyframe at time 0, then change the content of the text and keyframe it at time 3.00 seconds. Now play back the animation.